I am going to review with you how to solve systems of equation using the methods of elimination and substitution. So let's first talk about these two different methods and when to use each. So elimination is a method that we use where we add the two equations together and we try to get either the x variables or the y variables to eliminate. In order to do elimination, we want to have two equations that are set up in a format where the x's and the y's and the constants are all aligned with each other in the two equations, or some situation where it's easy to make that happen. I'd say in of these two problems, number 2 is more of an elimination problem. Substitution, on the other hand, is a method where we want to have at least one equation that has x or y by itself on one side of the equal sign. So we want an x equals or a y equals for one of our equations. We have that happening right here in the first equation. So I would say for me, the first equation is more of a substitution problem. So I am going to go through and work through both of these problems. We'll do number 1 using substitution and number 2 with the elimination. All right, so let's start with substitution. The idea of substitution, since I have this y equals, that means that any place in the equation where I see a y, I am allowed to replace it with this thing that y is equal to. So I'm going to be using that negative 4x minus 1 to replace my y in this equation. So I am going to rewrite this second equation, but I'll leave out the y. So 6x minus 2y equals negative 12. And I left out the y here because in place of y, I'm going to put the thing that y is equal to, negative 4x minus 1. When we do that, we end up with a more complex equation than we started with for either of our equations, but the nice thing about this equation is it only has x's in it, and so we can now solve this and figure out what x is. So my first step in solving, I am going to distribute this negative 2. We'll be very careful with our negatives here. Negative times a negative, this is going to give me a positive 8x. Negative times a negative, this is also going to be a plus. 2 times 1 is 2 equals negative 12. And I make a lot of mistakes with negatives, so I'm just going to go back and double check that I got my signs correct there. All right, parentheses are gone. I have some x's that I can combine together here. 6x and 8x, that's 14x. We've simplified as much as we can. Now it's time to start solving. So let's work to get this x by itself. We'll do minus 2 on both sides to get 14x equals negative 14. And one final step to get rid of this 14. That 14 is multiplying by the x, so we'll divide on both sides by 14 to get x equals negative 1. Now we're not finished yet because I still need a value for y. So I've got half of my solution. To find the other half of my solution, we're going to go back to one of our original equations. Usually it's the one that was the y equals or the x equals equation. I'm going to take this equation, I'm going to rewrite it, y equals negative 4x minus 1. But you'll notice I left out the x. And I did that because we now have a value that we can use in place of x. X is negative 1. So I can just simplify here and I'll know what y is. So negative 4 times negative 1 is 4. 4 minus 1 is 3. When we write our solution to a system, we want to give both the x and the y values as an ordered pair. X comes first. So negative 1 was my x value, and 3 was my y value. And there's my solution. All right, I'll show you very quickly how you can check to make sure that your solution is correct. This involves going back to both of our original equations and putting these two values in place of x and y. So I'm going to rewrite my first equation, y equals negative 4x minus 1. Let me go ahead and copy down my second equation as well. 6x minus 2y equals negative 12. And I'm going to put my negative 1 in place of the x here and here. And I'll put my 3 in place of the y here and here. What I'm hoping is that once we simplify on both sides, we're going to get the same number on both sides. So this is just 3 equals negative 4 times negative 1 is 4. 4 minus 1 is 3. So 3 equals 3. That's good. That checks out. Let's make sure the other equation checks out. 6 times negative 1 is negative 6. Negative 2 times 3 is also negative 6. Negative 6 minus 6 is negative 12. We've got the same number on both sides again, so that also checks out. So that means that our equation is correct. Okay, moving on to the elimination problem. All right, let's have a look at the second set of equations. So the goal here is we want to add these two equations together. But when we add them together, we want either the x's or the y's to eliminate. So we want them to be set up so that we're adding the same thing. For example, if I had a positive 4x and a negative 4x, these would cancel. Or if this was a negative 5y and I added this positive 5y, those would cancel. But we don't have that happening right now. So what we want to do is we want to modify our two equations, or one of them anyway, so that that happens. So if I look at my x's, I've got this negative 8x, and I'm thinking I can turn this negative 4x into a positive 8x. And if that was a positive 8x, then these would eliminate. And I can do that by multiplying. So I'm allowed to multiply one equation or both equations by any number I want. I am going to choose to multiply my bottom equation by negative 2. And I'll show you the reason why. Let me copy over what my new equation would be. This bottom equation, negative 2 times negative 4 would give us 8x. Negative 2 times 5 is going to give us negative 10y. Negative 2 times 0 is still 0. And I'm going to just copy my top equation over. It did not change at all. So I have changed the bottom of equation, and if you look at the x's now, when I add this negative 8x and this positive 8x, those two things are going to eliminate. They're going to cancel each other out. That's why we call this elimination. So when we go to add these together, those are eliminating. They're going away. My y's will not eliminate. I've got 7y minus 10y, that's negative 3y. Equals, and then negative 24 plus 0 is still negative 24. And that leaves us with a nice simple little equation that only has y. We can now quickly solve that for y. So let's divide on both sides by negative 3. That'll cancel, leaving us with y equals 8. All right, that's only half of our solution though. We need an x value as well. So just like before, I'm going to go back to one of my original equations, and it really doesn't matter which one I choose. I think I'm going to use the second one because it has smaller numbers, but we could just as easily use the first one. So let me copy down the original second equation, and when I get to y, I'm going to leave it out because I have a value for y. So negative 4x plus 5y equals 0. I've left the y out though because I know what y is. Y is 8. Now I can go ahead and solve this equation. So let's simplify. 5 times 8 is 40. And we'll do some steps of algebra to get this x by itself. Negative divided by a negative would be a positive. So I have an x value, I have a y value, we're ready to write our final answer. Our solution should have an x and a y value separated by a comma. My x value was 10, y value was 8. So I believe that 10, 8 is my solution, but I'm going to check just to make sure. Checking is a pretty quick process. I'm going to rewrite my two original equations, but leaving out the x's and y's. And let's put 10 in for my x's, and let's put 8 in for my y's. And just like before, I want to make sure I end up with the same number on both sides. So negative 8 times 10 is negative 80, and 7 times 8 is 56. Negative 80 plus 56 is negative 24, and that matches on both sides, so that checks out. Second equation, negative 4 times 10 is negative 40. 5 times 8 is 40. Negative 40 plus 40 is 0. We have 0 equals 0. That also matches. So we've checked both equations. Our solution works in both. Therefore, we know it's correct.